Michael. How are you doing? Oh, doing better. Still in the chest condition phase. So still taking it easy. Well, good. I'm glad you're doing okay. Tomorrow will be the real test. I'll be going back to work. I'll make sure to take some Dayquil. That should help. Ooh, where? So, oh, understandable. Yeah, there's just, it's a minefield right now. There's just so much chaos going on and crazy going on, and so many people think that they are so right and the other person is so wrong. So it's just cantankerous all around. Hi there, Lexi Bear. I'm glad that you're growing with your emotional journey, though, that you're seeing that there's things you can improve on and working on doing that. That's always a good thing to practice. Well, earlier I was doing, okay, so yesterday I made the mistake of thinking that would be a simple thing to go ahead and upgrade my RAM. Hold on, before I go into that. Right, true test. Michael says the true test is one word on the fire, under pressure. How do we handle it? Yeah, for sure. So, hi, Kineasy. Good morning to you. But yeah, so I made the mistake thinking it'd be simple to just upgrade my RAM. Well, it wasn't. So I did upgrade my RAM, but I didn't realize that my computer would have to have a hard drive in place to be able to boot, and it doesn't. And there's no way that I can update the boot option away from the hard drive that doesn't exist to the SD, the solid state drive that does. What's the time over here? Over here is Pacific Standard Time, so right now it is 4:25 Pacific Standard Time. So we're pretty much in late afternoon territory over here where I'm at. So my laptop is bricked, for at least for the time being. So today I got like a 2:45, 2 hour 45 minute, 3 hours, something like that live stream, looking up laptop specs, because this has been something I've been having to look into anyway. So now this right here is called, it's called PM C++ on for Dummies. Yeah, my laptop's currently inoperable until I can figure out how to make it boot. Oh, you're in Switzerland and it's currently 1:26 in the morning. Gee, I don't know if you're just up very late or you just had to get up very early. But either way, yeah. So the goal is to do like 30 minutes. Yeah, kind of. Like I should have realized that there was, I thought, oh, I'll just put the RAM in. It'll be beautiful. It'll run great. I will stop having game crashing. It's cold there? Probably. I imagine Switzerland is cold. I think I know enough of geography to realize that in the winter time, which you are definitely in, since Switzerland is above the equator, you would be getting cold. Oh, and if I remember correctly, it's more of a closer to the northern hemisphere. And then there's the mountains, and every time mountains in the Alps, I think they are But anyway, every time mountains are in play, the altitude gets up, coldness goes up. That part I remember from taking geography back in the day. And also, we do have some mountains out here. Usually in the winter, they're the ones with the snow. So that was, got to do a little research stream for a few. Now we're doing some C++ all for dummies, and the goal is I'll be doing a third stream today. Again, I can't really do the dancing with my lungs as they are without risking making things take longer to recover, which I think is a terrible idea. I have finally learned that that's a terrible idea. It took a while. All right, here we go. Let's get some reading time in. I'd say a good 30 minutes of reading is a good thing to strive for. So for those parts where I don't feel like saying every little thing, that's what I show on camera. But other than that, I'm pretty much just in the camera. 30 minutes in 5, 4, 3, 2, 1. All right, here we go. Creating and using dynamic arrays. Sometimes when you don't know the array size you need until runtime, the default arrays provided with C++ rely on static sizes. In other words, you need to know what size array you need at the time you write the code. Unfortunately, the real world is dynamic. It changes. The earlier sections of this chapter discussed a number of array alternatives, such as stacks, queues, and dequeues. Well, decks. However, these solutions all require that you use a library. They also tend to increase the memory requirements of your application and slow it down as well. You have another alternative in the form of dynamic arrays. The following sections describe dynamic arrays and show how to use them. Configuring the IDE. Dynamic arrays aren't usable in earlier versions of C++. You need to reconfigure code, blocks to provide the support required to use them effectively. This means adding support for C++ 11 extensions to the language. Again, this right here is called the 3rd edition. The most recent version of this book that I found was the 4th edition. So this information is probably different. So we can say at least C++ 11. To do this, choose Project, arrow Build Options. You see the Project Build Options dialog box. Get the have G++ follow the C++ 11 ISO C++ language standard checkbox as shown in Figure 6-1, and then click OK. This is effectively a review and a read through, so I don't actually do any of the things that they're talking about doing. Your IDE will now allow you to use newer language features required to work with dynamic arrays and many other new extensions. Declaring a dynamic array. A dynamic array relies on the heap, the common area of memory that your application allocates for the different functions your application use. See the heaping and stacking the variables section of Book 1, Chapter 7 for more details. You create, that's something I covered in an earlier live stream at some point, I don't remember which, but there's a playlist. So you create a pointer to a variable of the correct type and then allocate memory for the resulting array. The functionality for performing this task is found in the new .h file, so you need to include it as part of your application. The dynamic array example shown in Listing 6-12 demonstrates the use of a dynamic array. Okay, now we show things in the book. This right here is a screen cap of how things looked for code, blocks to be able to get things to set up to be able to use dynamic arrays. It says figure 6-1, configure code : blocks to allow use of new language features. And then this right here is listing 6-12, creating and using dynamic arrays. Hashtag include IO stream. Hashtag include new. Using namespace, standard, int main, int how many, int star, din array, C out, how many numbers would you like? Inline, C in, how many? Din array equals new, not throw, int how many? If din array equals null pointer, C out, error, could not allocate memory. Else, for an I equals 0, I is less than how many, I plus plus, din array, I equals I. C out, displaying entries in line, for an I equals 0, as long as I is less than how many, increment I. C out, din array I, in line, delete, din array, return 0. The example begins by creating variables to hold the number of array elements and the array itself, which is a pointer to an array of int elements. The application asks you how many, oh, that's right. I don't need to show that part. The example begins by creating variables to hold the number of array elements and the array itself, which is a pointer to an array of elements. The application asks you how many array elements to create. It then uses the new operator to create the dynamic array, din array. Notice the technique used to do this. The new operator is followed by no throw. What this tells the application is that if there isn't enough memory to create the array, to return a null pointer value, which is simply a pointer that doesn't point to anything. Tip. Normally, the application would display an incomprehensible error message that only geese could love if there wasn't enough memory. Using the no-throw approach gives you the opportunity to handle the error differently. The application handles the error by displaying a human-readable error message if din array equals null pointer. You work with a dynamic array just as you do any other array. The example shows how to fill the array with data and to display the data on screen. The array has the same capabilities, advantages, and disadvantages of any other array. However, when you get done using the array, you need to use the delete trace operator to delete the dynamic array and free the memory it uses for some other purpose. The output from this example looks like this if you request for array elements. How many numbers would you like? 4. Displaying entries 0, 1, 2, 3. Working with unordered data. Creating data that has a particular order is appealing because it's A, easier to search, and B, certain tasks such as removing old elements are easier. However, creating an ordered set of information is also problematic because you need to spend time keeping it in order. Newer versions of C++ provide access to an unordered set that is both searchable and easy to maintain. It has the advantage of adding the data in any order in which it comes. There is no overhead associated with trying to keep the data in a particular order. The following sections provide an overview of using unordered data. Using standard, spelled STD, : unordered _ set to create an unordered set. Like the other containers discussed in this chapter, an unordered _ set provides a particular method for storing data in a manner that makes it easy to access later. In this case, you have access to functions that insert, with the parentheses, and erase, also parentheses, elements from the container. A special function in place makes it possible to add new elements only if the element doesn't exist. Otherwise, the unordered set will allow as many duplicates as you want, and you can easily count them using count. Curly brace. I mean, parentheses. It's also possible to use the find function to track down elements that you want. Special functions tell you when you're at the beginning or end of the set. Remember, the unordered underscore set container is found in the standard library. However, you need to enable C++11 extensions in the IDE in order to use them. The Configuring the IDE section of this chapter describes how to configure code : blocks to provide the required support. Manipulating unordered sets. The easiest way to see how an unordered set works is to create one. The unordered set example shown in listing 6-3 demonstrates how to use the various unordered underscore set features to maintain a listing of colors. Listing 6-13, creating and using dynamic arrays include IOStream include unordered set, using namespace standard int main unordered set strings colors. Okay, underscore set, fine. Colors that insert red, colors that insert green, colors that insert blue. If colors that find red does not equals colors that end, C out found red inline, else C out red missing inline. Auto return value equals colors dot in place red. If return value dot second, C out red is already in set inline, else C out red added to set inline. See out there are color dot count red entries inline. Return value equals colors dot in place orange. If return value is not second, see out orange is already in set inline, else see out orange added to set inline. Colors dot erase red. Listing 6-13 continued. If colors dot find red does not equals colors dot end, C out found red inline, else C out red missing inline, return 0. The example begins by creating a new unordered underscore set colors. Notice that this is a template, so you need to provide a type for the information the set will hold. It uses the insert function to add 3 colors to the set. The find function makes it possible to look for a particular value in the set. When the value is missing, the end function returns true, which means that the current position within the set is at the end. This example uses the auto data type. It's a type you can use when you don't know what type to assign to a variable. Return is used to detect when a value that you want to add to the set using in place already exists. If the value already exists, the unordered underscore set refuses to add it when you call in place. On the other hand, if you call insert, unordered underscore set will add duplicate entries. To remove entries from a set, you call erase with the value you want to remove. In this case, the example removes the color red. It then searches for red using find. As you might expect, red isn't found this time. The output from the example is as follows. Found red. Red is already in set. There are 1 red entries. Orange added to set. Red missing. Yay! I hope red's not missing out. Sorry, I cannot time this right. Okay, chapter 7. Yay! Finally on to chapter 7. Book for chapter 7. Let's check the time. 16 minutes, a little over 16 minutes. Okay. Oh, here we go. Chapter 7, working with lambda expressions. In this chapter, considering the problem that lambda expressions solve, writing your first lambda expression, using lambda expressions in real-world programming. The previous chapters in this book focus on the Unified Modeling Language, UML, and how you use it to better model applications. Chapter 6 moves on to design patterns, which actually help you implement a model. This chapter takes the process one step further by looking at lambda expressions, an elegant method of turning a model into a math expression. Let's say that you need to calculate the number of widgets produced in an hour before you can print out the value. Adding the equation directly to the existing code might look bulky, but adding it as a separate function makes the code hard to read. Lambda expressions provide a middle ground where you can define the calculation in an easy-to-read manner without creating a separate function. Technical stuff. Unlike many of the odd terms you've encountered so far in the book, we programmers have nothing to do with the term lambda expression. You can blame it on the mathematicians for once. It's actually a kind of calculus that was introduced by Alonzo Church in the 1930s, and it's used as shorthand for complex equations. The equations are anonymous. That is, they aren't given a name. For once, the programming version of something found in math is actually easier to understand and use than what Alonzo Church created. We'll show you how to use lambda expressions to define simple functions that you only need to use in one place. They don't need a name because you won't use them again. It's sort of a disposable function, and they come in really handy for those times when you need to do something simple, but you want to separate it from the main function. Think of lambda expressions as a kind of function within a function, a nested function. Did I lose chat, or just nobody just is chatting? All right, let me check. Remember, lambda expressions aren't usable as part of early versions of C++. In order to work with most of the examples in this chapter, you must configure the project to use C++11. The Configuring the IDE section of Book 4, Chapter 6 tells you how to perform this task. If you don't perform the required configuration, you see an error message when you attempt to compile the example. Hold on, let me get that. Ooh-wee. Getting it pulled up on my TV. All right. You know what? Hold on. That was the other stream. Okay. It's live. Is it not going? Oh, is this not working? Or that's not working? Oh no, it's working. Well, okay then. Just when I think my hair is doing good things, I'm seeing that it's not. Oh well. I'm not worried about it. Okay, so here we go. Creating more readable and concise C++ code. And I guess nothing's going on in the chat. One of the advantages of using C++ is that you can create concise code that's easy to read. Because you can see more of the code in one glance, C++ is often easier to understand as well because you don't have to scroll the editor page to see the entire solution to a particular problem. However, there are some types of C++ problems that did require a rather verbose solution in earlier versions of C++. Starting with C++11, developers have a new technique for solving these problems in ways that bring C++ code back to its concise roots. You could solve a number of C++ development problems using lambda expressions, but the typical problem is one of making the code more concise and easier to read. There's absolutely nothing wrong with the problem example shown in Listening 7-1. It works just fine as shown. Okay, we're going to go over that, but first I got to drink some water time. Listing 7-1, defining a problem solved by lambda expressions. Include IOStream, include algorithm, include vector, using namespace standard, class my functor, public, void operator, int x, see out x inline, void process vector, vector int, ampersand vet, my functor func, for underscore each, vet that begin, vet that in func, int main, vector int, my vector dot push underscore back 1, my vector dot push underscore back 2, my vector dot push underscore back 3, my vector dot push underscore back 4, process vector, my vector. In this case, this example creates a vector, my vector, and populates it with data. And it then calls process vector to perform a task with the data in the vector. The call to process vector creates a functor, a special class of object that acts as if it's a function named func, spelled F-U-N-C. This is an extremely useful kind of class that I explore further in the functors section of Book 6, Chapter 1. For now, all you need to know is that it's a simple kind of class that acts like a function. The for underscore each algorithm demonstrated fully in the creating improved loops using for each section of Book 6, Chapter 5 is part of the standard library. It processes each element in vect. The vector passed to process vector, starting at the first element defined by vect, spelled F-E-C-T. Sorry, V-E-C-T. Defined by vect.begin, and ending with the last element defined by vect.end, using func. And yes, this is all seems very familiar from when I took advanced object-oriented programming. When you look at my functor, you see a definition for an operator that requires the single input x. All that the code does is output x to the console, so you see the following output from this example. So here is the output. 1, 2, 3, 4. So again, that was the code. That's the func. That's the vet.in through to the vet.end, and that's the func. X changes. And then that creates this output. Defining the essential lambda expression. The intent of a lambda expression is to make code shorter and easier to read. It creates a new method for presenting code. However, it doesn't actually create a new C++ capability. What you're doing is using the same techniques, but in a different manner than before. The following sections help you create your first lambda expressions so that you get a better idea of precisely how they work. Defining the parts of a lambda expression. The example in the previous section is perfectly usable. However, the functor is only used one time in the example. This situation happens relatively often, and it causes confusion for developers who need to work through the resulting code. A lambda expression makes it possible to incorporate the functor as part of the for_each algorithm, as shown in the solution example in listing 7-2. All right, let's look at that. Listing 7-2, defining the lambda expression solution. Include IOStream, include algorithm, include vector. Using namespace standard, void process vector, vector and ampersand vet for _each, vet that to begin. How's this different? Hold on. So that's still for each. Interesting. For each, vet dot begin, vet dot end, in x, see out x in line, in main, vector, my vector dot push underscore back 1, my vector dot push underscore back 2, my vector dot push my vector dot push underscore back 3, my vector dot push underscore back 4, process vector, my vector. As you can see, using the lambda version of the example is much shorter and easier to understand because you no longer require a separate class to process the data in the for each algorithm. I see. A lambda expression always appears like this. Straight braces, pair, in x, inside of a pair of parentheses, and then curly braces, the thing you want done. In this case, the C out. And then the X, C out the X and then the inline. So it takes all of this, which was, this is main, and then this was the class that had to be made to be used in main. But instead of that, you just come on in, you have your process vector as its own thing instead of a separate thing. So effectively you have two classes in main wherein you kind of merge these two things by using the lambda expression, where you just only have to deal with the process vector, which has that part, which is effectively what you're doing here. But you don't need to have your my functor func. Instead, you're just using this sort of idea specific to what you're doing. So in this case, it's the pair of straight braces. You're in X, and then the thing that you're doing within your curly braces, as shown there. Oh, there you are. I'm glad you're here. Are you okay? Remember, the pair of square brackets followed by any input arguments. Oh, and we're in chapter 7. Hurrah. The pair. Oh, and look. See how this is all the red? That's what we've read. That's what's left. Wow. Amazing. Remember, that part of square brackets followed by any input arguments in parentheses always needs to be at the beginning of a lambda expression. The code you want to execute, set between a pair of curly braces, always takes up the rear. Like any function, a lambda expression can accept multiple input variables and provide a return value. The beginning square brackets are called the capture clause, and You see it used later in the chapter. Lambda expressions can include other features, including the ones you see demonstrated in the Developing with Lambda Expressions section of the chapter. But every lambda expression includes the following three features: capture clause in square brackets, argument list in parentheses, executable code in curly braces. Relying on compile detection of return type. Lambda expressions can process information and present it directly. This is pretty much the end of the semester. That's pretty much what we had to implement lambda expressions for the last part of the advanced object-oriented programming course that I took back in fall of 2023. Man, amazing. Relying on compiler detection of return type. Lambda expressions can process information and present it directly, or provide the information as part of. Am I done? Okay, hold on. I'm technically done, but I feel like going for another 20 minutes. 5, 4, 3, 2, 1. And then from here, I'll break so I can do something for dinner. And then after that, then we're going to try some Kingdom Hearts time. Rely on compiler detection of return type. Oh, and the goal is tomorrow after work, after I get situated and stuff, returning to the looking at laptop stuff. Because I don't expect to be able to be in dancing mode for a bit. I kind of, lungs are not my friend. Even right now, I'm like super tight chested right now. Relying on compiler detection of return type. Lambda expressions can process information and present it directly, or provide information as part of a return type. Simple lambda. Okay, I'll restart that. Yeah. I'm going to restart the timer, but I'm fighting with my watch for a bit. There it is. Oh, okay. Restarting timer in 5, 4, 3, 2, 1. Start. 2 minutes starting now. Rely on compiler detection of return type. Lambda expressions can process information and present it directly, or provide the information as part of a return type. Simple lambda expressions can return information without telling the compiler much about it, because the compiler can automatically detect the return type. The return type 01 example in listing 7-3 demonstrates how you would implement a lambda expression that returns data that is automatically detected by the compiler. Oh, great. Let's do that. Listing 7-3. Using a compiler detected. Return type. Include IOStream, include algorithm, include vector, using namespace standard. Void process vector, vector int, ampersand vet, vector will result dot resize, vet dot size, transform vet dot begin, vet to vet dot end, result dot begin. Notice that is a lambda expression. Ooh. I think so. It has to start off with the, no, that's not, but this part is. Okay. Transform vet dot begin, vet dot end, result dot begin, comma. Then they put in, this is the lambda. This is what starts with the straight braces, and then the arguments, and then the executable code. C out dot set F iOS : bool alpha For underscore each, result.begin, result.end. Again, here is the lambda. In this case, it is a pair of straight braces bool x. That's the argument it takes. And the thing you want done is see out x in line. Int main vector int my vector dot push underscore back 1, my vector dot push underscore back 2, my vector dot push underscore back 3, my vector dot push underscore back 4. Process vector, my vector, as in the previous example. This example and most of the examples that follow creates a vector int named my vector, fill it with information and pass it to process vector. Process vector receives the data as vet and processes it one element at a time. Process vector begins by creating a vector bool named result to receive the results of the data processing. In this case, the processing occurs in a transform function that receives the beginning and ending position of vet, along with the beginning position of result and a lambda expression. In order for the transform to work, the lambda expression must return a value that defines precisely how the transformation process works. In this case, the process is a simple comparison of the input value x with the number 3. When the transform is complete, result contains a list of bool values that indicate whether the individual numbers in vet are greater than 3. To see these values as true or false text output rather than numbers, you need to call cout.setf parentheses here. Inside of that it says iOS : bool alpha. The code then uses a for underscore each loop to display the individual values in result. Here's the output you see when you run this example. False, 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 true. Given that the input values in vet are 1, 2, 3, and 4, it's true that the last element of vet 4 is greater than the number 3. Using a transform with a lambda expression, as shown here, is a great way to reduce the code required to perform various kinds of bulk comparisons, among other transformation-specific tasks. I assume I haven't been missing any chats. Using a specific return type. Sometimes the lambda expression is complex enough that the compiler can't figure out what return type to use. Often you see an error message during the compilation process when this occurs. Fortunately, it's easy to fix this problem by simply telling the compiler what sort of return type to expect. The return type 02 example shown in listing 7-4 demonstrates how to perform this task. No, ma'am? Oh, hi. Okay, it's working nicely. Thank you. But also, what do you mean, no, ma'am? What happened? Listing 7-4 using a specific return type. Include IOStream, include algorithm, include vector. Using namespace standard, void process vector, vector int, ampersand vet, vector bool result, result.resize, vet.size, transform vet.begin, vet.end, result.begin. Then the lambda expression as follows. Your straight braces pair, int x is your arguments, gets the bool, and the executable, where is it gives bool? I think it gives bool. Return, this is exactly called return x greater than 3. C out.setf, iOS, : bool alpha, for underscore each, result.begin, result.end, then this lambda expression, which is composed of the argument of x, which is a bool, C out, and then the executable code is C out x in line. Int main, vector int, my vector, my vector dot push underscore back 1, my vector dot push underscore back 2, my vector dot push underscore back 3, my vector dot push underscore back 4, process vector, my vector. Thank you. Thank you, Ryan. Oh, you're right. I'm not missing the chat. Thank you very much for confirming that I'm not. Sorry, my memory is just the worst. All right, here we go. Remember, the essential code application flow and output are the same as return type 01. However, notice this example changes the lambda expression to include a return type. Whenever you want to define a return type for a lambda expression, add the arrow operator. That's what I thought that was. That was the return type. Oh. And the return type, which is bool in this case. So, the return type, that's saying that you're returning the arrow operator, that's saying you're returning a bool. So that's cool. Bool is a binary. It's either 0 or 1, true or false. If you switch over to alpha, that's kind of nice to be able to have that. Remember, I think it's true is 0 for C++. Sometimes it's the other way. Okay, I did remember. Tip. There are other reasons to use a specific return type. In some cases, providing a specific return type allows the compiler to better optimize your code so that you obtain better performance from your application. Using this approach can be quite helpful when you suspect your lambda expression is going to be processing a considerable amount of data. In this case, you won't see any difference in application speed between return type 01 and return type 02 because the data set is so small. Using the auto keyword. The auto keyword is a new feature added since C++ 11. What this keyword does is provide a shortcut method for defining the type of a variable, no matter what the variable may ultimately contain. Essentially, you use the auto keyword to save typing time. Rather than type the full text of a lambda expression each time you need it, you simply type the name of the variable that contains the lambda expression. Remember, when you use the auto keyword, you're asking the compiler to determine the type of a variable based on how the key variable is used. This means that it must be possible to determine the type of the variable by examining the context in which it is used. When you use the auto keyword, these outcomes are possible. The compiler will determine the type automatically and assign it to the variable. Well, Ryan is having a moment. Okay, then. The variable will receive a correct type, but not the type that you had originally envisioned, such as assigning a long where an int might serve better. Two or more types are possible, which means that the compiler will display an error message saying you can't figure out the ambiguous assignment. Determination of the variable type is impossible given the context, and you must specifically assign a type to the variable. The auto keyword is used in all sorts of situations, and you see it pop up several times in the book. I'm really curious. Oh, wow. What? Oh, screw the timer. Let's just finish book 4. That would be amazing. Okay. Screw the timer. I don't think I can beat the timer, but I'll have it on, but I'll probably just keep going anyway. We're almost done with book 4. What? Okay. The auto keyword is used in all sorts of situations. Familiar. Listing 7-5. I'll just say it again. The auto keyword is used in all sorts of situations, and you can see it pop up several times in the book. The return type 03 example is shown in listing 7-5, demonstrates how you can use the auto keyword with Lambda expressions to store the associated code and make it easier to access within the application. Okay, let's do that. Wow, we're going to be done with book 4? What? Oh my goodness, that is amazing. All right, celebrate. Listing 7-5. Using the auto keyword to automate the return type. Hashtag include IO stream. Hashtag include algorithm. Hashtag include vector. Using namespace standard. Void process vector, vector int, ampersand vet, vector bool result. Result.resize, vet.size. Auto transformer equals the lambda expression with the argument of x and the executable of returning x greater than 3. Transform vet.begin, vet.end, result.begin, transformer, cout.setf, ios, bool alpha, auto, do print equals lambda expression with argument of bool x and executable code of cout x inline. Is that the argument of x or the parameter of x? Yay. Hold on. Yeah, the capture class is, so it's capturing nada. I have it right. Okay, yay. You would think I would have learned that by now, because again, I had to do that a lot toward the end of that one class. Usually if I learn something, it stays learned. It just takes a while till it's learned, that's all. All right, let's see. So yeah, the argument of bool x and the executable code of cout x inline for underscore each result.begin, result.end, do print, it mean vector, int, my vector.push underscore back 1, my vector.push underscore back 2, my vector.push underscore back 3, my vector.push underscore back 4, process vector, my vector. The overall effect of this application is the same as return type 01 shown in listing 7-3. The code uses a transform to determine the true value of whether the value in vet is greater than 3. The output is precisely the same as well. The big difference is that the lambda expression is placed within a variable that you can then use as needed. As a result, the transform code is made simpler and easier to read, albeit not quite as short. That's pretty fun. Using the auto keyword with other types. The auto keyword can be used in any situation where you want to define the type of a variable. For example, you could use it in a for loop, should you wish to do so, as shown in the auto keyword example. For auto I equals 0, for as long as I is less than 8, increment I, cout I inline. Depending on your compiler, when you view I in the debugger, you'll find that the compiler has made it an int, the same type you would have used when choosing the type manually. Of course, you probably won't use the auto keyword in this manner because typing int is actually shorter than typing auto. Even so, you can use auto anywhere the compiler could determine the type of a variable based on the variable's context. Even something as simple as this following code, also part of the auto keyword example, works just fine. Auto greeting equals hello. See out greeting inline. In this case, the compiler will create a const char star variable for you. However, there is a problem with this particular bit of code. If you were to assume that the compiler has created a string instead, you might write code like this. Auto greeting equals hello. See out greeting.length inline. Making the wrong assumption means the code won't compile. You receive an error message stating error request for member length in greeting, which is of non-class type const char star. To obtain the string that you need, you must specifically declare the variable as type string. Sometimes you also get the wrong type in situations that aren't quite so clear. For example, the following code should rely on a long data type. Auto large number equals 15. Large number plus equals 21474834647. See out large number in line. When you run the code, you get an answer of negative 21474834634, which is clearly wrong. The problem here is that the compiler assumes you want an int variable. To obtain the long variable you must specifically declare the variable as type long. When you run the example using a long variable, you get the correct output of 21474834662. Developing applications with lambda expressions. The previous section of the chapter acquaints you with the essentials of working with lambda expressions. There are a number of ways in which you can expand a lambda expression to meet specific needs. The following sections show how to use some of the more common methods. Creating lambda expressions with multiple inputs. Some lambda expressions require you to provide multiple inputs. The two most common examples are checks for equality and sorting algorithms. However, any instance where you must compare one value to another in order to create the desired output will usually require two inputs at a minimum. I guess either way that works. The multi-input example in listing 7-6 performs an equality check between the content of a vector and an array. I am slow, but that's not new. Time's out, but again, we are going for gold. We are going to finish book 4. Yes. Listing 7-6, providing multiple input values. Include IOStream, include algorithm, include vector, using namespace standard, void, compare ranges, vector int, ampersand vet, int values, auto result equals equal, vet.begin, vet.in, values, the lambda expression, taking the arguments of int x and int y, with the executable code of return x equals y. Cout.setf, ios : bool alpha, see out, the values are equal, result in line. Int main, vector int, my vector dot push underscore back 1, my vector dot push underscore back 2, my vector dot push underscore back 3, my vector dot push underscore back 4. Int my ints equals 1, 2, 3, 4. Compare ranges, my vector, my ints. All right. The example begins by creating a vector and array. It then calls compare ranges and supplies both items as input. The compare ranges function relies on the equal algorithm to determine whether the two objects contain the same values. The 4 inputs determine the beginning and ending of the vector comparison range, the list of values to compare it against, and a lambda expression to define the comparison method. Notice that the lambda expression takes two parameters, in this case x and y, both of which are int values. The equal algorithm acts somewhat like a for underscore each algorithm in that it checks the values one at a time. The lambda expression must return a Boolean value that expresses whether the two inputs are equal. When you run this example, you see the following output. The values are equal, colon, space, true. To try changing one value in either the vector or the array, you see that the output now changes to false. Because in order for something to be true, every single thing has to be true. If only one thing is false, it's all false. Working with the capture clause. In some cases, you can't access a value you need in a lambda expression by passing it as a parameter. The value is available as part of the function, but the lambda expression can't see it because it's essentially another function. The way to overcome this problem is to use the capture clause to access and use, that is, capture the value you need. Once captured, the lambda expression can access the value as if it were passed as a parameter. The capture example in listing 7-7 shows how to capture and to use a value within a lambda expression. Ooh. Ceiling time, yes. Okay. Just so messy. Okay, here we go. Listing 7-7 using the capture clause. Include IOStream, include algorithm, include vector, using namespace standard, void, process vector, vector and ampersand vect, int exclude, for underscore each vet.begin, vet.end, exclude, and the capture clause. Int x is the argument. Again, this is the lambda expression. The executable code is if int x is not an exclude, see out x in line. Int main. Vector, int, my vector dot push underscore back 1, my vector dot push underscore back 2, my vector dot push underscore back 3, my vector dot push underscore back 4, process vector, my vector 3. The caller provides both vet and exclude as parameters to process vector. However, only the values in vet are available to the lambda expression, unless the lambda expression captures the value within the square brackets at the beginning of the lambda expression as shown. Because exclude appears within the square brackets, the lambda expression can use it to perform the comparison. When you run this example, you see the following output: 1, 2, 4. But where did exclude come from? Is that... Well, it says in exclude. So we know exclude is an int. So I guess it has to get... Okay, 3. 3 is what exclude is. Right, okay. That explains why 3 is missing. Right. Okay. Ooh. Remember, notice that the value of 3 is excluded. Oh, okay. Should just keep reading. From the output, because this is the value passed as part of the call to process vector. When you provide a different value, a different number is removed from the output. No, but not if it's not there already. Like if it's not there, okay, that's when you have to do some exception handling. When you provide a different value, a different number is removed. from the output. Like if it's not in the range, like if the number doesn't exist in there, but additionally if it's like asterisk or something, like if it's a character that's not a number, it's like that's going to cause issues. The main purpose of the capture clause is to provide a means of passing additional information to the Lambda expression to aid in processing the data it receives. Sorting data using a Lambda expression. One of the most common tasks that applications must perform before presenting data to the user is placing it in some sort of sorted order. Although a computer can easily locate a specific value in a long list of values, even if that list isn't sorted, users are quite different. The longer the list, the more important it becomes to present the information in a particular order. Remember, at one time, developers had to create their own sorting algorithms for every need. The topic of sorting received more than a little emphasis in computer science classes. Yes. Today, however, a developer only needs to worry about sorting algorithms with when a specific kind of sort is needed. The sort algorithm, or if you're trying to deal with big data and you want to try to get the most efficient thing possible, then you want to, make sure you're using something that can do that without taking forever in a day or days and days and days. Oh my gosh. Flashbacks to this time last semester. This one thing just wouldn't work for nothing. So I'm glad. I'm really glad that my partner figured out a way to do it. For big data, I'm so glad. Granted, I don't agree with a lot of the methods she used. Anyway, no point in getting all messed up and pissed off about that again. Okay. Today, however, developer only needs to worry about, the sort algorithm used by itself would perform most generic sorting tasks. However, you still need a custom sorting method to perform specialized sorts, such as when you're working with a structure or complex data. For the sake of simplicity, it's easiest to review sorting using a simple vector. The sorting example in the scene 7-8 provides both a standard sort and a custom sort on the same vector. This year so far is a lot less stressful than this time last year. I will say that. That is a plus. It's a darn shame things ended the way they did, but they ended well with me graduating, so yay. Let's use 7-8 sorting data using a lambda expression, include IOStream, include algorithm, include vector, using namespace standard, void standard sort, vector int, ampersand vet, sort, vet.begin, vet.end, cout, using the standard sort, inline for underscore each, vet.begin, vet.end. Again, this is our lambda expression. It has the argument of int x, and the executable code is cout x inline. Void process vector, vector int, ampersand vet, sort, vet.begin, comma vet.end, then a lambda expression right there. It has the arguments of int s1 and int s2, and the executable code of return s1 is less than s2. Cout using a custom sort inline for underscore each vet.begin, comma vet.end, then a lambda expression with the argument of int x and the executable code of cout x inline. Int main vector int my vector dot push underscore back 11, my vector dot push underscore back 2, my vector dot push underscore back 33, my vector dot push underscore back 4. Standard sort my vector, process vector, my vector. Remember, look at the standard sort function first. When an application calls sort, it places the resulting data in the same object that it received. At the first, vet contains unsorted data. However, after the call to sort, the data is sorted using a generic sorting method. Notice that you don't need a lambda expression to perform a generic sort. The process vector function looks almost the same as the standard sort. The difference is that the function relies on a lambda expression to perform a custom sort. Sorting is the process of comparing one value to another, so the lambda expression receives two inputs, S1 and S2. By knowing which value is greater, sort can determine whether to place the two values in the list. Where to place the two values in the list. The result is the same in both cases. Here is what you can expect to see from the example as written. Using the standard sort 2, 4, 11, 33. Using a custom sort 2, 4, 11, 33. Of course, this might lead you to believe that remains sorted as an experiment change, return S1 less than S2 to return S1 greater than S2. Try the example again, and you'll see that the lambda expression approach lets you present the data in reverse order. Using the standard sort 2, 4, 11, 33, using a custom sort 33, 11, 4, 2. Specifying that the lambda expression throws exceptions. Yeah, that's good. An exception is an indicator of an unexpected occurrence within an application. The occurrence could be due to an error, such as someone sending a function an incorrect value. I was just talking about that. However, the occurrence could just as easily be due to a loss of network connection, also true, or a full disk drive. The important consideration here is that the occurrence is unexpected, that the application couldn't automatically check for the potential problem and proactively compensate for it. The process of indicating the unexpected occurrence is called throwing an exception. Lambda expressions can throw any sort of exception required to indicate an error condition. However, there are methods of indicating the precise sort of exception that a lambda expression might throw. By indicating the kind of exception, you make it possible for the compiler to optimize the lambda expression and make it faster, more efficient. Remember, in some cases, the lambda expression never throws an exception. Perhaps the functionality it provides is quite simple, and there literally isn't anything that can go wrong in the sense of generating an exceptional condition. When this is the case, you add the throw clause to the lambda expression as shown here. Auto my lambda straight pair throw. Also, sorry. Then your straight parentheses pair throw return true. It's far more likely that your lambda expression will throw a specific exception. For example, the input may be outside the range. Yeah, that's the usual one. The lambda expression expects, and there isn't any good way to compensate for this condition. Even in this situation, telling the compiler specifically which exception the lambda expression will throw allows the compiler to better optimize the lambda expression. But better optimize the code, making it faster. The exceptions example in listing 7-9 shows just this situation. Listing 7-9, throwing an exception with a lambda expression, include IO stream, include algorithm, include vector, include standard except. All right, show up here. We're almost done with book 4. Wow. Using namespace standard, void process vector, vector in, ampersand vet, sort, vet.begin, vet.end, lambda expression. Nothing in the capture clause. Arguments are in S1 and S2. Throw out of range. And there's the executable code. If S1 is greater than 100 or S2 is greater than 100, throw new out underscore range value over 100. Return S1 is less than S2 for underscore each vet.begin, comma vet.end. Again, this is lambda expression with the argument of in x. Throw, this is the executable part, C out, X inline. Int main. Vector int my vector. My vector dot push and square back 11. My vector dot push and square back 2. My vector dot push and square back 33. My vector dot push and square back 4. Remove comment to see the exception. My vector dot push square back 101. Process vector my vector. When you run this example, normally you see the same output as shown for the custom sorting portion in the previous example. However, when you remove the comments from my vector.push underscore back 101 and run the example, you get the following exception message. Terminate called after throwing an instance of standard : out underscore of underscore range. This application has requested the runtime to terminate it in an unusual way. Please contact this application's support team for more information. Notice that the code used to display the output from the example doesn't throw any exceptions. The code is defined in a way that allows the compiler to perform additional optimization. With an example of this sort, it would be hard to actually quantify the speed difference, but there is such a difference, and it would become apparent with a larger data set. Oh boy. Oh boy, oh boy. Ryan, I hope you're here still, because that's it. Book 5, Reading and Writing Files, coming around the corner. Yes, because, just a reminder, this big book of books, 3rd edition of C++ All-In for Dummies, is 6 books in 1. Whoa, what? We're coming to the end? What? Accordingly, great, I'm glad you're here. So according to the, I'm so excited. According to this, we'll be starting in on book 5. I don't know when, this week for sure. Whether or not tomorrow, I don't know, because I do have to get back to laptop looking. But this is where we're starting. Page 615. Right there. Let me put some light on there. 615. Book 6 starts right there at page 681. Wowie. The end is nigh, in a good way, I think. And then the last chapter, well, let's say this. The appendix starts on page 73. So effectively 100 pages is what book 6 is. Oh my goodness. What? Oh, that's great. So, oh man, I remember when I used to read so often and so avidly and be able to just finish books in days. But I don't care that this has been taking me roughly a year to get done. I'm so glad that we've been able to make this a YouTube series, because I was not getting any kind of progress before I started doing that. Oh, great. All right. Well, Ryan, you're worried that we weren't finishing C++. I think you mean this, but we're almost done. Look at that. Just a little bit. 200 pages or less, effectively, because the appendix is the last, 20 pages. Whoa, yes, that is pretty cool. We have finally gotten the heck out of book 4. Yes. Okay, so for me, I'm gonna go get some yummy dinner time. Gotta figure out what I want to eat. You know, those little sausage things, those are pretty good. Maybe I could do that again. Or I could go for a vegan thing. That's true. Let me think about that. Or I could, ooh, mac and cheese. That's not vegan fully, but it's kind of vegetarian. That could be a happy medium. Oh, okay. I could work with that. Okay, either way, I'm gonna go figure out some food time. This time just by myself. I already wasted you guys time with food time during lunch during today's laptop searching. But that's the thing. I already ate some dead animals yesterday and the day before, and I usually like to alternate and not eat dead animals sometimes. It's great. Gosh. I wonder if I want to get pinged from YouTube for saying that. Probably. Ryan, I forgot I was YouTubing and there's certain words that you're not supposed to say. Yeah. Either way, I need to go get some food time. And then, um, I already got things set up with the PlayStation Remote app on my phone. I also got the PlayStation 4 wireless controller set up to my phone via Bluetooth. Like what? Oh, the words? Come on now. I'm sure there's a list available on Google. It's probably not that hard. I'm not interested in going through the list because I already said one of the words is probably on the list just by reading what you said. And it wasn't you or animals, but probably the other part. But yeah, so we're going to try out some Kingdom Hearts live streaming. Oh, and I got, ooh. So this is a full on, well, minus. No. This is a full on, this entire week will be a work week. What? No, not at all. I'm the one who should be remembering what I should be saying. That is definitely a me. But yeah, so we're gonna try it. We're gonna try it. Oh yeah, I was saying I already got a potentially I have a job set for all week, or not. I don't know. It says 5 days, but technically that that means it seems like it should be 6 days. So it's like okay, one of those days is missing, but I don't know which. But I should know tomorrow when I go in what exactly they want help with. Like I don't agree with Ryan disliking Ryan. I think Ryan's pretty freaking cool and awesome. And I wish Ryan would cut down on some of the negative self talk. Uh, so I don't know if you're feeling like Kingdom Hearts time. And I don't even know if you're having to go bouncing around or already bounced around somewhere. Yeah, what's your week looking like? Did you have traveling? Did you have traveling going on, or are you still pending traveling, or is this a not travel time for you? You travel every week. Okay, got you. But like, have you gotten your traveling done, or is that still something you need to do? Like as far as your new location. Oh, so you still have to get going. So it looks like another late flight then. Or early? I don't know. Either way, red eye tomorrow. Oh, okay. Well, okay. So you might have some time for some Kingdom Hearts um live stream time. Okay. And then as far as okay, well then what time are you going to be not busy tomorrow? I know it's not I know it's not guaranteed, but like likely to not be busy. I mean, I'll probably just do my usual anyway. Something after 4 my time. Because, ooh, I gotta say, being done with everything by 8 my time is great times. Because I sure do like my bedtime at 9 p.m. my time. Traveling during the day. Okay, well, I'll be working during the day, as I was saying. Maybe I forgot that part. No, I said that part. So effectively, I'll be working all day, and so I don't plan on doing any kind of streaming until like after 4, as I typically do. Okay, so that's probably fine then. Well, all right. For now, I'm gonna go break for dinner, and then we're gonna come back and try some Kingdom Hearts time. And Ryan, hopefully you're available because you're seeing that the game capture was lagging out. So I'm kind of hoping you can see if there's any improvement with me trying to use my phone versus my currently bricked computer back when it was just a potato. But if you're not available, I get it. No worries. But yeah, before you mentioned anything, I thought everything was just doing awesome. I mean, I knew the game capture would break and break and break and break, but I didn't realize it was additionally lagging out. Sure. Okay, well, hopefully. Well, all right. I'm going to get yummy food time. And like I said, I already have things prepped. PlayStation 4 is hanging out over there. It looks like it got unplugged somehow or another, so kind of have to look into that. Um, and while I was doing the thing I was doing, I was charging up the wireless controller, but I can do that a little bit more while I do my food time. Pass out watching sounds like a plan. It, I expect grinding. I don't expect much progress. I expect grinding. Uh, the goal is to grind enough to get. The first thing I can do is I can try to do the fight, but before I do that, I can go check and make sure that Sora is a party of one, because technically he didn't meet Donald and Goofy yet. And so if that's the case, then I just need to do enough grinding to get protect for Sora, as far as some kind of defense accessory. I would only need to get it for Sora. And then I have to try to get enough potions to be able to stock high potions. I feel like it's gonna cost a lot more. And also HP level as Sora is in, a potion will do it. It'll recover enough of the HP. It's just my timing is kind of whack. And hopefully being able to just watch things on my phone with the screen capture will be less of a pain in the butt than trying to watch via OBS with the little tiny screen and all the OBS stuff underneath. And so I'll actually be able to concentrate, and then also not having to worry about game catcher breaking, and constantly breaking. That might be helpful for a boss fight. It's possible. Anyway, I don't know if I'll get anywhere at the boss fight, but at the very least, I'll get some good grinding in. So that's the plan for Kingdom Hearts for tonight. Okay, sounds like a plan. Alrighty. I'm gonna eat and catch you in a bit. Okay, Ryan, see you. Kingdom Hearts time, hopefully. And anyone else, good night to you. Or if you're interested, go ahead and catch me over at Kingdom Hearts time. But for now, time to eat time. So, yeah. Yo, Zavacanja Brown, what is up? I'm actually having to go right now, but if you're interested in Kingdom Hearts time later, please do. It's going to be a grinding, and I'm going to be testing things out by using the PlayStation Remote Play app on my phone, since my computer is currently bricked. It might end up having a better experience than my computer was able to do. which would be kind of funny, but we'll see. Either way, bye for now.